Recording in progress.
Hello everyone. Today we will going to see some practice questions from the chapter Hydrocarbons. Disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the same. Let's start with our first question. Isomers of hexane, based on their branching, can be divided into three distinct classes, as shown in the figure. So, first class is first one, which is having two hexanes, isomers of hexane, you can say. Uh, in the first structure, the branching is different. In the second structure, the branching is different. There is a second class where also the hexane isomers are present, having the different branching. In the third class, there is a structure of hexane having no branch. So these are the three classified branches of the isomers of hexane. The correct order for their boiling point is, we have to tell the correct order of the boiling point. Options are highest in first, then second, then third, highest in third, then second, then first, highest in second, then third, then first, or highest in third, then first, then second. So for the given question, the correct answer is option B, that is highest in third, then in second, and then in first. Using the concept 15.35, this problem is based on the boiling point of isomeric alkanes. Right? So this problem is basically focused on the isomeric alkanes boiling point, and as we know, more the branching in an alkane, lesser will be the its surface area, and hence lesser will be its boiling point. So as described, that these are the three categories, or these are the three distinct classes which for which the isomers of hexane has been divided. In the third class, we have a simple long chain structure of hexane having no branch in it. In the second class, we have branch, or you can say we have single branch at different positions in the hexane structure. And in the first category, you can see that there are two branches present, or in the at the different positions in the structure of the hexane. On moving from left to right, from left to right, that is from third to first. Branching, you can see branching increases. As I said, that in the third there is no branch, in the second there is one branch, and in the first there is two branches. So the branches increasing from left to right. Surface area decreases. As the branching increases, that means surface area is decreasing. Also, boiling point decreases, and as the surface area decreasing, boiling point will also decrease. Hence, the correct choice or the correct order is in option B, and thus our correct answer is option B. Let's move on to the next one. 1-bromo-3-chlorocyclobutane, when treated with two equivalents of sodium in the presence of ether, which of the following will be formed? We have to tell about the product. Options are A option, having bromine as a side product only, and there is a cyclobutane. In the B option, we have chlorine as a side group and the cyclobutane. And in the C option, we have only a structure of cyclobutane. And in the D option, we have a structure of cyclobutane where the second or the second and the fourth, or you can say first and the third, are connected. So for the given question, the correct answer is option D. Using concept 15.2, this will be the this will be the reactant 1 bromo 3 chloro cyclobutane as given in the question. Right, there is a cyclobutane structure where 1 bromine and chlorine are attached at the opposite carbons, and you are reacting with you are treating it with sodium, or you can say two equivalents of sodium, and the reaction following is Wood's reaction. This alkyl halide will convert to a biacyclo 110 butane. Okay, this product. So our final product is this, and the reaction is known as Wood's reaction. And this product is given in option D. Thus, our correct answer is option B. Let's move on to the next one. How many compounds are possible on monochlorination of 2-methyl butane? So when you do the monochlorination of 2-methyl butane, how many compounds are possible? Options are 2, 4, 6, or 8. So for the given question, the correct answer is option C, that is 6. Now using the concept 15.34, so this will be the reaction following that when you react 2-methyl butane, that means at the second position we have a methyl side chain, otherwise four number of carbons are present in our parent chain, so it will be 2-methyl butane. So when you do the monochlorination of 2-methyl butane, that means when you react the 2-methyl butane with 1 chlorine molecule in the presence of light, it will form 4 products. You can see first, second, third, fourth. Okay, and first one is having a long chain of butane, having at the second position methyl group attached, and at the fourth position we have a chlorine. In the second structure, there is a two side chains in the butane structure where one is methyl and other one is chlorine atom. In the third structure, we have again two side chains but at the same carbon, that is second carbon. One is methyl and one is chlorine. In the fourth structure, we have only one alkyl halide, which is methyl chloride as a side chain on the second carbon. So these are the four number of compounds we get after the monochlorination of 2-methyl butane. Out of these four products formed above, second and fourth are chiral. So they are considered as chiral compounds, right? They are chiral. So as they are chiral, produced in enantiomeric pairs, that's why they are produced in the enantiomeric pairs. That means they have their pairs along with them. So giving total of 6 monochlorination products, and that is why along with these four, two more are existing compounds which we get after the monochlorination of 2-methylbutane, which are nothing but enantiomers of the chiral compounds we obtain, that is the structure second and the fourth, right? So total 6 compounds we get after, or you can say that total 6 monochlorination product we get or possible, and that is why we have our correct answer as option C. Let's move on to the next one. Consider the following reaction. We have a reaction given where you can see there is CH3, CHD, CH3, CH3. And this compound is reacting with the bromine free radical, giving us X plus HBr molecule. We have to identify the structure of major product X. We have to identify that what is X. Options are CH3, CHD, CH3, CH2 free radical, CH3, CHD, CH3, CH3 free radical, CH3, CD, CH3, CH3 free radical, and CH3, CH free radical, CH3, CH3. So these are the four structures which can be a major product, which is X. Right? You have to select the correct one. So for the given question, the correct answer is option B. Using concept 15.34, bromination is highly selective, which occur at the carbon where the most stable free radical is formed. Okay, so the process bromination is a highly selective process. That means it has happened only in certain way, in a certain manner, and it will only occur at the carbon where the most stable free radical will be formed. So you can see this is our given product, or you can call it that this is the given reactant we have in the question, plus it is reacting with the bromine free radical forming X plus HBr, right? So the compound that will be formed will be CH3 CHD single bond C, CH3 CH3 free radical. You can see this is a tertiary free radical. This is tertiary free radical and plus the 1 molecules of HBr as depicted in the question. So a tertiary free radical is the most stable free radical, because you can see this is tertiary. How? The carbon having the free radical is or free, single charge, is having one bond attached to CH3, one bond attached to CH3, and one another bond attached to CH3. So single carbon is attached to three different carbons, that it is a tertiary compound, or you can say tertiary free radical, and tertiary free radical is the most stable one. That is why bromination will happen in this manner, and the X will be this tertiary free radical, and this structure is present in in our option B. That is why the correct answer is option B. Let's move on to the next one. When cyclohexane is poured on water, it floats. Because of what reason? So it is said that when cyclohexane is poured on water, it start floating. Why? Options are cyclohexane is in boat form, cyclohexane is in chair form, cyclohexane is in crown form, or cyclohexane is less dense than water? For the given question, the correct answer is option D, that is cyclohexane is less dense than water. Using concept 15.35, alkanes are less dense than the water. That means the density of water is more than the density of alkanes, and thus alkanes floats over water. This is the basic concept, that if the density difference is present between the floating object, or between one object and the another object, and you mix them, so one start floating over the other, and the floating one will be having the less density than the other one, right? So on this basis, we just conclude that alkanes are less dense than the water, and that is why they start floating over the water. So the correct answer is option D. Cyclohexane is less dense than water. The carbon hydrogen bond distance is longest in what? So we have to tell that in the given options, from which compound you can say that the distance or the bond distance of carbon hydrogen is longest. Options are C2H2, C2H4, C2H6, or C2H2Br2. For the given question, the correct answer is option C, that is C2H6. Using the concept 15.36, CH bond with sp3 carbon will be longest in C2H6. Okay. So if the bond is singular, you can say if the bond is single, not double, not triple, if the bond is singular, and you know the carbon is having sp3 hybridization, that means that bond distance will be the longest. And if you observe from the options, these both conditions are present in C2H6 molecule, right? So the longest CH bond is in C2H6. Thus, the correct answer is option C. Its highest boiling point is expected for. So, from the options, you have to tell which one of the compound are having the highest boiling point. Options are isobutane, N-octane, 2233 tetramethylbutane, or N-butane. So for the given question, the correct answer is option B, that is N-octane. Using concept 15.35, boiling point of alkane increases with the molecular mass, or you can say molar mass. Among the isomeric alkanes given, branching decreases the boiling point, right? Because if you increase the branching in the isomeric alkanes or in the alkanes, it will decrease its boiling point because the surface area will decrease. Therefore, the N-octane has highest boiling point, higher than 2233 tetramethylbutane, which is an isomer of N-octane. Okay, so this N-octane and this 2233 tetramethylbutane are isomers. So basically, but N-octane is a single chain, 8 carbon chain, right? Single, has no branch. And but 2233 tetramethylbutane has 4 number of branching and total 8 carbons. So carbons are same, but here the branching is present, here no branching are present. And as the branching will increase, the boiling point will decrease. So the boiling point of 2233 tetramethylbutane will be lower, and among the options, the highest boiling point will be observed in N-octane. That is why the correct answer is option B. Which of the following compounds does not dissolve in the concentrated sulfuric acid even on warming? Options are ethylene, benzene, hexane, or aniline. So, for the given question, the correct answer is option C, that is hexane. Using the concept 15.5.3.1, ethylene absorb sulfuric acid forming CH3CH2O SO3H and get dissolved. Benzene with warm H2SO4 undergo sulfonation reaction and get dissolved. Aniline, on the other hand, with H2SO4 forms anilinium sulfate salt and get dissolved, while hexane, a hydrophobic molecule, does not react with sulfuric acid and thus it is remain insoluble. And we have to find the compound which will not dissolve in the concentrated sulfuric acid. So you can see that all are dissolving and forming a particular or respective compounds with sulfuric acid, but hexane is a hydrophobic molecule which will do not react with H2SO4 and it will remain insoluble in the solution. So our correct answer is option C. So for the given question, the correct answer is option D, that is N-hexane. Using concept 15.35, among the alkanes, boiling point increases with the molar mass. Okay, we just talk about this, that among the alkanes, boiling point depends on the molar masses and the branching, So among the isomeric alkanes, branching decreases, the boiling point, right? Because if the branching will increase, the boiling point will decrease. Therefore, the N-hexane has highest boiling point because it has no branching at all. So N-hexane is a single long structure where 6 number of carbons are attached directly with each other. No branching is present, so it will be having the highest boiling point. So our correct answer is option D. Let's move on to the next one. Marsh gas mainly contains what? So you have to tell about the marsh gas, you know, constituents from the given options. So the options are C2H2, CH4, H2S, or CO. So for the given question, the correct answer is option B, that is CH4. Using the concept 15.35, methane is produced due to the decay of vegetables or animal organisms present in swamps and marsh by the action of bacteria. So when bacteria react with the vegetable, left out vegetables or animal organisms, they will start decaying them. Okay, present in swamps and marsh, and due to this method of formation, methane is also known as marsh gas. That is why the methane has other name, that is marsh gas. So marsh gas is nothing but CH4. That is why our correct answer is option B. Let's move on to the next one. The incorrect statement regarding conformations of ethane is. So, after looking at the conformations of ethane, what will be the incorrect statement from the given options? Options are: the conformations of ethane are interconvertible to one another. The dihedral angle is staggered. Conformation is 60°. Eclipsed conformation is most stable conformation. Or ethane has infinite number of conformations. So for the given question, the correct answer is option C, that is eclipsed conformation is most stable conformation. Using the concept 15.37, the statement which is given in option A, B, and D are the correct one, while the statement given in option C is incorrect. The correct form of statement C is eclipsed conformation is least stable conformation of ethane. Okay, so it is not the most stable, but it is the least stable conformation of ethane. So this is the correct statement of the statement given in option C. It is interesting to note that in all the conformations, the bond angles and the bond lengths remain the same in the Newman structure. So basically, in those structure, all the conformation in all the conformations, the bond angles and the bond lengths remain same, whether it is eclipsed or staggered. Okay. So we have to select the incorrect statement, which is option C. So our correct answer is option C. Which of the following conformations will be most stable? The options are, you can have a look at the 4 images given for the options. First one is this having 2 methyl group at the end of the carbons, and they are arranged differently. In the B option, we have this structure where also 2 methyl groups are arranged at the last and first carbon, but they are arranged differently from the first option. In the option C, we have again a conformation where 2 methyl groups are attached, but they have different conformation from A and B. And again, in the option D, we have 2 methyl groups attached at the first and the fourth carbon, where the 2 methyl groups are arranged differently from A, B, and C. So these are the 4 options. You have to select the conformation which will be most stable. So for the given question, the correct answer is option D. Using concept 15.37, N-butane forms more than one type C2C3 rotation of conformers. So you can see this is the structure of N-butane having 4 carbons, first, second, third, and fourth, where the bond is between C2 and C3, and this rotation around the C2C3 bond can have be more than one type, right? So the option A is given this structure which is fully eclipsed form, and this is a fully eclipsed form which has maximum steric repulsion, because you can see that methyl groups and hydrogens are close to each other as as much as possible. So there is a maximum steric repulsion between the alkyl group CH3. So it is a least stable conformation. In the B conformation, you can see this is partially eclipsed form, because the methyl are present at 120 degrees something from each other. So partially eclipsed form has lesser steric repulsion than the eclipsed form, and so it is more stable than eclipsed form. It is, if you compare, it will be more stable from the fully eclipsed form structure. In the third structure, we have gauche form, where the methyl groups are slightly away from each other. So this is a gauche form. This is more stable than the eclipsed form, again, because in the eclipse there is a highest or maximum repulsion, steric repulsion. But if you compare, so gauche form will be more stable than the fully eclipsed form. And in the fourth structure, we have anti or staggered form, where the methyl groups are opposite to each other, arranged opposite to each other. So this is anti or staggered form, which is most stable due to the lowest steric and torsional strains from the all the given structure, four structures. This D structure is the anterior-staggered form structure, is the most stable because it is having the lowest steric and torsional strains between the methyl groups, right? So that is why this structure given in the option D will be considered as most stable, and thus the correct answer is option D. Okay. So let's start with the first question. In the following structures, which one is having staggered conformation with maximum dihedral angle? So, from the given options, we have given four structures, right? We have to tell that which one structure is having a staggered conformation with a maximum dihedral angle between. So, the options are: option A involved a Newman formula where you can see two methyl groups are attached at the ending, and all rest are hydrogens. In the option B, we have a Newman formula where two methyl groups are attached again, but the conformation changed slightly from the first option. In the C option, we have again a Newman formula where the two methyl groups are attached, but the structure or conformation is slightly changed. In the D option also, we have the similar kind of Newman formula, but only the position of the methyl groups are changed on the two carbons. So for the given question, the correct answer is option C. So using the concept 15.37, staggered form, which is given in the C option, has a dihedral angle of 180 degree, right? So we have asked in the question that which structure from the options is having staggered conformation which is at the maximum dihedral angle. Okay, so the correct answer is option C, in which you are having a staggered conformation, and also the dihedral angle is the maximum, which is 180 degree. The spatial arrangements of atoms, which can be converted into one another by rotation around a C, single bond, are called conformations. So we have defined here the concept we use uh, for giving the answer of this question, that the spatial arrangements of what, of atoms. Okay, so how the atoms are arranged in the space which can be converted into one another, so they are interconvertible, they can be converted into one another by rotation around a C single bond, they are called conformations in the Newman formulas, right? So it has two extreme cases. One such conformations in which the hydrogen atoms attached to two carbons are as close together as possible is called eclipsed conformation. So in the when you notice or when you observe the conformation or the rotation among around a C single bond in the conformations in the Newman formula, there are two cases possible. First cases is that one such conformation will form when the hydrogen atoms around the two carbons in a C single bond, so that hydrogen atoms are as close as possible, they arrange themselves as close as possible. Such conformation is called eclipse or eclipsed conformation, right? Whereas the second case involves when the hydrogens are as far apart as possible, is known as staggered conformation. So there are two type of conformations after the rotation of atoms around the CC single bond. So two cases are possible. In the first case, eclipsed conformation forms, eclipsed conformation, in which the hydrogen around the CC single bond arrange themselves as close as possible. And the second case, in the second case, staggered conformation form, where the hydrogen are as far as possible from each other around the CC single bond. Okay. So as the question was that the option is having staggered conformation and having a maximum dihedral angle. So our correct answer is option C. In the option, in the structure C, we have the maximum dihedral angle, which is 180-degree, and also the conformation is also observed as staggered conformation. Let's move on to the next one.